Hey everybody, welcome back. Today 6.3 showing quadrilaterals are parallelograms. That is coming your way, so buckle up, let's go! Okay, so today we are going to, guess what, show that a quadrilateral is a parallelogram. There's a few theorems for you, so please make sure you write these down. I would like you to write down the example as well. So write down both sections. You know what? Why don't you just make it a nice table? Okay, so pause now, write these three theorems down, and I will explain in just a second. All right, it says, if one pair of opposite sides of a quadrilateral are parallel and congruent, that's very key, not just parallel, but and congruent, then the quadrilateral is a parallelogram. Okay, so you need to know that they are parallel and congruent. Next one, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So instead of one being parallel and congruent, you just need the opposite sides that are congruent to make it a parallelogram. Okay, so again, we are talking about quadrilaterals that are parallelograms. Last one, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, there are going to be multiple shapes that are parallelograms that you know of, talking about rectangles and squares and so on and so forth. Okay, those are also not just rectangles and squares, but they're also parallelograms, they're also quadrilaterals, so on and so forth. Okay, so what I want you to do is make sure you know these three theorems because we will be using them in the future. Okay, so next to write these theorems down as well. They're just two more theorems about parallelograms. Pause. So if you look at these two, they are going to be, again, theorems and conditions for parallelograms. If you know these are true, then you know that it is a parallelogram. So if it says, if an angle of quadrilateral is supplementary to both, I repeat, both of its consecutive angles, then the quadrilateral is a parallelogram. You can't just have one. You need to have both of its consecutive angles that are supplementary. Okay, the reason why, because then you can but then you can justify that this will also be x, which proves that previous theorem that both pairs of opposite angles of a quadrilateral are congruent. So they kind of go hand in hand here. Okay, last theorem that you have here today, it's going to be if the diagonals of a quadrilateral bisect each other, remember that word bisect, okay, then the quadrilateral is a parallelogram. What does it mean to bisect? Well, it means basically to cut in half. So if AC is a bisector of BD, if you look at this picture, then BZ has to be equal to ZD, and AZ has to be congruent to ZC. Not all four of them congruent, but they have to be, Z has to be that midpoint of BD and AC. They have to bisect each other, cut each other right in half. All right, so let's go on. Let's try a problem and see what we come up with. So it says, determine if the quadrilateral must be a parallelogram. We're going to justify our answer. So when you come up with an answer, yes or no, tell me why that is true or why that is not true. Give this one a shot. All right, so when you look at this, we know that one pair of opposite angles are congruent. Okay, what else do we know? Nothing. We don't know anything else. So according to our conditions that we had earlier, we needed that both opposite angles needed to be congruent for it to be a parallelogram. So is this a parallelogram? No, because there is only one pair of opposite angles congruent. You need both pairs. What's the other theorem that we could know about this? or about parallelograms. If you look at it, we also could have said, we also needed that these two would be supplementary to one of the consecutive angles. Okay, so that's one of the other way. Okay, moving on. Okay, so same idea here. I want you to determine if the quadrilateral must be a parallelogram. Again, justify. Justify your answer. Don't just give me a yes or a no, but tell me yes because of this, or yes because of that, or no because of this, no because of that. Okay, so make sure you justify each of your answers. So give this one a shot. All right, so if we look at this, we know that 107 is going to be obviously congruent to 107, and we also have a 73-degree angle. Okay, so according to our conditions, or according to our theorems, is this a parallelogram? Yes, it is, absolutely. Now, which theorem allows us to say that that is a parallelogram? Okay, if you remember 6, 3, 4 here, in other words, the 73-degree angle is going to be supplementary to both of its corresponding angles. Not corresponding, consecutive angles. So 73 is going to be supplementary to both its consecutive angles. Awesome. Okay, so here it says show that JKLM is a parallelogram for A is equal to 4 and B is equal to 5. So we need to show that it is a parallelogram. And what we're doing here is we are using the theorems and assuming that it's going to be assuming that it's going to be a parallelogram, and all we need to do is we need to show that it's a parallelogram. So looking at these, show that it is a parallelogram. Give her a shot. All right, so if we are going to show that this is a parallelogram, we need to make sure that we have that JL and KM bisect each other. Okay, so if it is going to be congruent, we need to know that JN is going to be equal to LN. We also need to know that MN is going to be equal to Kn. That's the only way that that's possible. Okay, so what we do is we plug in A equals 4 for both equations and B equals 5. So for Jn, we have 7A minus 6. For Ln, we have 5A plus 2. Okay, so what is A? A is equal to 4, so I'm going to take 7 times 4 minus 6. 7 times 4 is going to be 28, minus 6 is going to be 22. Okay, for 5A plus 2, 7 times 4, sorry, not 7 times 4, is going to be 5 times 4. 5 times 4 plus 2, 5 times 4 is 20, plus 2 is 22. So are those equal? Absolutely. We need to prove that Jn and Ln are equal to each other, which we did. They both equal 22. Okay, now Mn. Mn is going to be 2b. To be or not to be? That is the question. Okay, so 2b, we know that b is 5, so we just take 2 times 5, which is 10. What is Kn? Kn is going to be b plus 5. What is b plus 5? That is 5 plus 5. What is 5 plus 5? 10. So if we look at this, we have 10 and 10. We know that Mn is going to be equal to Kn, which proves if Jn is equal to Ln, this is equal to this, Mn is going to be equal to Nk, okay, or Kn. What does that prove? That proves it is a parallelogram by which theorem? Theorem 635. Theorem 635, and that tells me that they both bisect each other, that the diagonals bisect each other. All right, so one more. We have one more problem for the day. I know you're excited to do this last one, so let's get her done. Here we go. Now it says show that quadrilateral JKLM is a parallelogram by using the definition of a parallelogram. First of all, you should be asking yourself, what is a parallelogram? Well, we know a parallelogram is a four-sided figure, okay, that has opposite sides parallel. Parallelogram, parallel. Okay, opposite sides parallel. So if I give you points, and I'm just going to give you, draw this shape here of J, K, L, M. If I give you that shape of JKLM, how do you know that it is a parallelogram? With points, how could you figure that out? Okay, I hope you're thinking in your head. As you think about that, how could we prove that they are parallel lines? What do we know about parallel lines that we learned last year? They have the same slope. They have the exact same slope. So in order for us to prove that this is going to be a parallelogram, we need to prove that we have the exact same slope. So when you look at this, JK has to be equal to ML, and JM has to be equal to KL. Their slopes have to be equal. So remember how to figure out how you find slopes. Give this one a shot to see if it is a parallelogram. All right, so if you remember how to figure out slope, remember it's m equals y2 minus y1 all over x2 minus x1. So if I look at jk, okay, the slope of jk, I'm going to take jk, which is going to be -1 minus -6 all over -4 minus a -1. Not -4, -1 at the end here. So when you take that -1 minus a -6, I get 5. And -4 minus a -1, I have -3. So that's the slope of JK. I'm going to do that same thing for ML. Okay, ML is going to be 5 minus 0 and 4 minus 7. When I take those, I have 5 over a -3. Do those have the exact same slopes? Absolutely. 5 over -3 is the exact same. So I know that ML is going to be parallel to JK. I need to follow that same system with JM and KL. So I have JM, which is going to be JM, which is equal to a -1. Sorry, not -1. JM is going to be -6 minus 0 all over -1 minus 7. -6 minus 0 is going to be a -6 all over -1 minus 7, which is -8. So 6 over 8 is my slope here. Okay, so if I look at this, that's my slope. How about KL? Okay, KL, my slope is going to be -1 minus 5 all over -4 minus 4. Here on top, I have -6 over -8, which is the same thing as 6 over 8. Are those the exact same? Yes, they are. So that shows me that they are parallel because I have both opposite sides are parallel because of their slopes. Okay, so JKLM is a parallelogram by its definition. So I prove that by finding their slopes, comparing it to the opposite sides, such as JK and ML, and JM and KL. So you might want to, when you look at this type of problem, draw shape first, and then find the slope. All right? Sweet. We are all done with 6.3. I will give you your homework tomorrow. Have a great day. See you later.